So we do the calculation. We take the calcium sulfate content, we determine the IAP or the Q, I'm not sure how you teach that, and we compare it to the solubility product of gypsum, and it turns out obviously that it's much too dilute. And so what's happening is the gypsum begins to dissolve, so you get cracks in the concrete, water gets into those cracks, gypsum begins to dissolve, and you get problems. That is the one time that I find students really listening to what I'm saying, because they now see, you know, who cares about my equilibrium concept? Why do I need to know those things? Well, you do need to know in order to explain these kinds of problems. And my best story, which I stole from a colleague friend of mine, is the story I tell about copper. My area of expertise really is in trace elements, heavy metals. And this copper compensation story is the best story. That's the story from, and this is the one that I'm not exactly sure how true it is anymore. It's been many years since I've told it, but it's the story from Scotland. So I asked the students, what is Scotland known for? What is the big export? So I get lots of ideas. And the one that I'm trying to get them is to say a Scotch, single malt Scotch. So they have a laugh from my students. So there's a lot of Scotch production going on in Scotland, obviously. How do they make Scotch? They talk about how to make Scotch. But one of the things they use are these very large copper pots for the actual distillation process. That copper slowly over time makes its way into the solution, and eventually it ends up in the waste materials, the sludge, the sort of solid materials, that then gets dumped into large piles as waste material on the property of the distillery. And several years ago, they had a problem with copper, elevated copper content in some local rivers and streams. And they found this because they noticed problems with fish kill. So there was actually copper toxicity in the fish in these streams and rivers. So I say to the students, what do you think is going on? What do you think is going on there? And that leads us into a discussion about these piles. What's happening in these piles, essentially, these are giant compost piles. What's happening in a compost pile? You get elevated CO2. You get very rapid respiration. You get elevated CO2, which means you get elevated carbonic acid, or you get elevated bicarbonate and carbonate. And copper loves to form a very strong aqueous complex with carbonates. And so the copper then, which you think would be very, very strongly held in these piles, because copper loves organic material, but that copper begins to leach out of the piles and leaches into rivers. So those are the kinds of stories I always find. The students that look like they're going to be asleep in the next 5 minutes, I've got them when I'm telling stories. So that, to me, is my best ammunition for getting students engaged in chemistry. It's not always particularly successful at the first year level, but I find it very successful. For example, in my second year soil science class, I do the same kind of thing. Okay, so that's another example. Next slide. Okay, what I'd also like to do is talk about, so that's the first year chem course, 2-semester chem course that I no longer teach. And if you want to ask me some more questions about that course, you can do that at the end. I do also want to talk about this liberal arts chemistry course I teach as well. It's called Chemistry Today. I use the textbook in that course, Chemistry in Focus. It's a Brooks Cole textbook. It's a really good textbook. And the way this course is structured, so remember, this is a course for students most of whom have never had grade 12 chemistry. Some of them haven't even had, is there grade 11 chemistry? Yes. Many of them have not even had grade 11 chemistry. So these are kids who want to do hotel and food administration. So the last time they took chemistry or biology for that matter was several years ago. So what I do in that course is I split the course into sort of 2 sections. The first section, we address some very basic general chemical principles. So we look at atoms and elements, just to remind them of the periodic table. We do compounds and chemical reactions. We do a very little bit of stoichiometry, but not a lot. just very basic. What is an acid? What is a base? Then the second half of the course is much more qualitative. So the first half is somewhat quantitative, the second half is very qualitative. And we look at, because they're hotel administration students, we look at household chemicals, biochemistry, pharmaceuticals, the chemistry of food, which is really the most important thing for them. And because I'm an environmental chemist, I stick in a little bit of environmental chemistry as well. Next slide. So let me just talk about the way, I'll talk about this in a minute, but the way the course is evaluated. This is a distance education course. Both of the first year chem courses that I teach now are, believe it or not, distance education, which is an odd thing because almost all of my students in both the courses are on campus. Okay? So I prefer to call them online courses. This course actually has a number of students taking it from a distance, and so does the grade 12 chem, because some people just need to get a grade 12 equivalent chem so that they can get into university. So I do have a few students taking it actually from a distance, but most people are on campus. Maybe Jonathan, you can talk about why there is this push to move towards distance education courses, but I think one of the reasons is it's a good money maker, these online courses. One reason, yeah. I actually did teach this course for a number of years in the classroom, and then it was converted to an online course. And when they did that, I at first was quite scared by the whole process. I really didn't think it was a good idea. I'm not sure what your views on online courses are. Didn't think it was a good idea. Didn't think I could have the same rapport or connection with students. I gotta say, being the critical thinker that I am, I actually have been surprised at how well these work. And they work well for two reasons. One, if you've spent time designing them, and we have a very good open learning distance education group on campus who helped me to design the courses. So they're designed very well, and they work very well, and I don't mean to toot my own horn, but I am an impulsive or obsessive, I should say, an obsessive email person. So these students get responses from me. I always say to them, you will get a response from me within 6 hours. Usually it's less than that. So I'm always online interacting with these students. So that's, I think, another reason that it works well. So they do sort of basic chemistry exercises. They have quizzes. They have a midterm. They have a final. They have problem sets they have to complete. But because this is a liberal arts chemistry, I decided to add something to the course that would not be so onerous from a quantitative point of view, because one of the things these students really struggle with is the math. They really struggle with the math. So I developed this project that the students do. It's a group project. It's a group project because there's 130 students in the class. And they're broken up into small groups of about 4 students each, and they're assigned a mystery ingredient list. And that mystery ingredient list essentially is an ingredient list that I have typed up for a bunch of household products in my house. So there's a cereal, there's a chocolate bar, there's a cookie, there's a hair conditioner, just a bunch of things that I found that I typed up. There's about 15 of them, and they're given a mystery ingredient list, and they're told that their job is to write an informative sort of pop ed piece that talks about the ingredients and then talks about it in such a way that they can at the end decide what it, or guess what it is that they're talking about. For the most part, students really like this because they don't really feel like it's chemistry. But from their perspective, the idea is, again, these are hotel and food administration students. Really, they're not going to become chemists. What they need is some familiarity with terms, and I thought maybe it would be a good idea for them to have some familiarity with food additives. So really, that's